Next up is Dr. Marco Ni, Professor of Civil and Environmental Engineering, and Ying Chen, Assistant Professor of Civil and Environmental Engineering with Northwestern University, as well as Dr. Alexandra K. Murphy, Assistant Professor of Sociology at the University of Michigan. And they will be presenting Learning Mobility Insecurity from Location Intelligence Data.
Thank you, Debbie. Good afternoon, everybody. Happy to be here. So today I'm going to present our work on learning transportation insecurity from mobile phone data. This is a CCAT-funded project, and I want to recognize our collaborator, Dr. Alex Murphy from University of Michigan and Dr. Ying Chen from Northwestern University. I would also like to recognize my my student, Tianxin Dai, who obviously done most of the work, and also we have our data collaborator, Peter Kivitsu. Also, I will mention some of the results I presented here from a previous collaboration with my colleague at Northwestern University, Dr. Amanda Staspalas, and her student. All right, I think I can. So here's an outline of my presentation. I will begin with an introduction of the mobile phone data. I will talk about the data set we used in our study, and then I will turn to a case study conducted before we launched this project. And I want to showcase the potential and challenges of getting useful information from this data set. In the third part, I will turn to our CCAT project, Learning Mobility Insecurity. This is still an ongoing work. So my plan is I want to share the current progress I've made, and then I will talk about next steps. So nearly everyone has a mobile phone these days. Okay, so when we are using the location-based apps on our phone, your locations are being stored and recorded and basically sold by the makers of the of those apps. And the companies will buy those data and then basically consolidate them into what we call location-based service data. So I'm not familiar with this industry, but I think there are many of those companies out there now, and so this data have become commercially available widely. So what is inside the data? So the data consists basically the timestamps and latitude, longitudes of the service rendered. So what is not inside the data is identifiable personal information. So we definitely cannot track the person behind the device. We can track the device, but we cannot track the person behind the device. So for this study, we acquired a data set from Pickwell SP000. This is a Polish data company we work with through our data collaborator, Peter Kivitsu. So the data covered 2 months, the February of 2021 and May of 2022 for the city of Chicago. So for each of these months, the data contains over 100,000 devices, unique devices. So this works out about 4% raw sampling rate for the Chicago's population. Because of the agreement we signed with the data company, we actually didn't have direct access to the data, to the location data. So we don't have the access to the raw data. As an alternative, we have our collaborator to pre-process the raw location data into the information we can use for our study. So basically, we turn the data into activity as well as trips. So we define activity as a group of data points that stay roughly in the same location within a given interval. So we define that interval in our study for about 15 minutes. So once determined, an activity is given a location and then a label. So the location is given in the form of census tract. So we can pinpoint the location for census tract. The label is based on the duration. For example, if we identify a home activity, so the location of that activity is defined is where a device spends most of the time outside the typical work time window. Okay, so that's what we call a home activity. We also define primary activity. The location of a primary activity is a location where a device spends most time other than home. And we also have the secondary activity. So those are obviously very crude classification, but for our purpose, we found it's adequate. Other than activity, we also define trips. Trips are a group of data points that connects two consecutive activities, right? So whatever that are not activities, these are considered trips. Right? So we have activities and trips, and this is what we work with. Now, I will quickly go over a case study we have conducted before launching the CCAT project. We have done a couple of these case studies, but given the time, I can only cover one. The results of this case studies have been published, have been summarized in papers that is currently under consideration for journal publication. So if you're interested, I will, toward the end of the presentation, I will be happy to share with you those articles. So in this case study, we deal with the representation issue in the mobile phone data. So our initial concern was that certain demographics, especially the vulnerable populations, may be underrepresented in these data sets, right? So that was our concern. But it turned out when we look at the results, we found that, in fact, the opposite was true. So if you look at the right plot, which shows the city of Chicago, the light color areas is associated with lower income areas, okay? And the black circles represented the representation rate, which is defined as a ratio between the number of devices and the size of a population in each census tract. So a larger the cycle, the higher the representation rate, okay? So I hope you can see that in this particular diagram, the lighter colored areas is actually associated with larger black circles. It's not that visible, but I can assure you that we confirm this with, by statistical analysis, we confirm it's statistically significant. So it's kind of counterintuitive, right? So why this happens? We have come up with some theory we actually wrote in the paper. Unfortunately, I don't have time to share with you here. I'd be happy to chat with you about what we think about why this happens. But I want to share with you one result, which has to do with the impact of Apple's privacy policy change. Right? So if you recall, in November of 2021, Apple changed their policy. Before November 2021, you automatically opt in for tracking. Okay. After that, the app has to ask you for permission to track you. Right. So that's a significant change in terms of policy. Now, if you look at the table, before the policy change in 2021, which is our first data set, the number of iOS devices in our data is about 51%, and this is comparable to what we see in the actual market share, which is 56% in 2021. But after the policy change in 2022, you see the the iOS representation in our data plunged from 51% to 37% compared to 54% in the actual market share. Obviously, this has significantly worsened. First of all, we confirm that there is a significant impact. This treatment effect has a significant impact, but also it worsened the overrepresentation issue in the data set, because obviously the iPhone users tend to be tend to have a higher income compared to an average user. So what are the takeaway from this case study we did initially? Obviously, we found that the mobile phone data could have significant representation bias, though it does not necessarily go the way we thought, right? So it could have, it does not necessarily match our stereotype. In this particular case, we think it's actually a good thing because it allows us for opportunity to study minority and disadvantaged groups since they appear to be overrepresented in the data set. But generally speaking, we believe that this actually confirms the potential of this type of data to complement and enrich traditional data surveys because of their scale and their spatial temporal coverage, right? So that's it's an encouraging result. Now let me switch gear and turn to our CCAT project, which is about learning transportation insecurity from our data set. So what is transportation insecurity? Okay, so we define transportation insecurity as a condition in which a person is unable to regularly move from place to place in a safe and reliable, timely manner because of lack of resources necessary for transportation. This is a term coined by my colleague, Professor Alex Murphy at University of Michigan. So transportation insecurity can be measured by transportation security index, and TSI, we call it TSI. So we can create TSI from a questionnaire that asks respondents a bunch of questions about their travel experience in the past months, right? Professor Murphy's team had developed different versions of TSI questionnaires, and in the shortest version of this questionnaire, in fact, it only consists of 6 questions, right? So you ask 6 questions, people respond to it, and you compile the response, and you get the TSI. So in the latest Detroit metropolitan area community survey that was administered in November of 2023, this TSI questionnaire was added into the survey. This, to my understanding, if I understand correctly, this is the first time TSI questionnaire was tagged on into a major survey. So there were about more than 2,000 respondents in this survey. Professor Murphy had done an initial study of the data, and they had made some initial findings. I think there's a report online. Basically, they found that minority, low-income, and female respondents tend to experience transportation insecurity more. They also find significant correlation with mode use patterns. For example, if you don't have a car, if you use different modes, multiple modes daily, that's an indication of transportation insecurity, right? So that give us some ideas where to look for transportation insecurity. Anyway, so in this particular project, we are looking for answering 2 questions. First, we want to know, can we extract features, especially mobility features from mobile phone data that are related to transportation insecurity? Can we do that? Can we extract the features from the data? Second, can we infer transportation insecurity using those features? So these are questions that we are attempting to answer. Now, our basic idea is a transfer learning, using a transfer learning method. By that we mean we start with the survey data. Okay, so we try to build we try to look for a relationship between different features, mobility features, and TSI, right? Based from the survey data, right? So if you look at here, we have different types of features: social demographics, built environment, mode use patterns, and so on. The good news here is that because we have the TSI questionnaire embedded in the survey, so we can have labels, actual labels of TSI, so we can actually build a relationship. Once we build that relationship or prediction model, we can then transfer that prediction model to our mobile phone data, right? For which we don't have labels. Okay, we don't have labels, but we can actually extract the features, similar features from the mobile phone data, hopefully, and then we apply the prediction model, and we can get the TSI. In this particular case, we try to classify the devices, the mobile phones, into transportation secure and transportation insecure, right? So that is the idea. Once we get the TSI classification, we then try to validate it. And this part we haven't really gone far enough. We didn't have good answer to how we're going to do the validation because we don't really have labels, right? Toward the end, if I have time, I will share with you some of our thoughts on how we're going to do the validation. So we will first build a classification model based on the survey data. And so here we treat the the secure and insecure as the dependent variable, and those labels will come from the 6-item TSI questionnaire, right? So that's our dependent variable. For the predictors or independent variables, we will have 3 categories, as I showed in the previous slide. We will have a built-in environment, such as road density, transit frequency. We also have social demographics, and I want to emphasize there are 2 types of social demographics. One we can get from individual respondents, right? So this is unique. We can get that from each response, but we can also get census tract level social demographics, right? So if we know where the individual live, we can get census tract level social demographics. Why this is important? Because for the mobile phone data, we don't have individual level social demographics. We can only rely on the census tract level social demographics. So if we want to transfer learning from the survey to the mobile phone data, we have to use census tract level data. Finally, we have the mode use variables, like how frequently use of different type of modes. We follow a standard supervised learning workflow. We will split the data into training and testing data using a k-fold cross-validation method, right? So we have X and Y, but then we'll split our data into different training and validation. So using the training data, we will build our model, we will fine-tune the hyperparameters, but then we use the testing data to the testing data to do the validation. In the testing, we will consider both the individual social demographics as well as census tract demographics. Okay. So let me show you some of the results we had. Right now we have built a random forest classifier. So we have the metrics that we use to evaluate our model include two metrics. One is accuracy, another one is specificity. So accuracy is basically just using using the test data to look at correct prediction over the total predictions. So it's very straightforward. Specificity is to identify is focused on the insecure population. So we look at the true negative over the true negative plus the false positive. So you can look at the performance, right? So if you use the individual, we have about 77% of accuracy and 81% of the specificity. So it's a reasonably good performance. But if we just use the census tract level social demographics, you can see that our accuracy dropped a little from 77% to 73%, but specificity does not really change. So this is very encouraging news in terms of transferability. That means we can actually transfer what we learn from the survey data, hopefully, to the mobile phone data. I think I'm gonna jump to the next step. I think I'm running out of time. So, for the next step, we have tested our model. We have now built our prediction model based on the survey. Next step is we're gonna try to extract the information from the mobile phone data and then and test our model on that data set. So the things that we need to do is we need to obtain the predictors from mobile phone data. And for the building environment and social demographics, these are relatively easy because once you identify home location of a device, you can just get the census tract information. You can grab those information there. What is hard, which we are still working on, is the mode use. How do you identify mode use of those trips, right? So now we have the trip points, but how can you know the mode? Once you have the mode. Once you identify the mode, which we will probably do using unsupervised learning method, and we will assemble the mode, the mode for each trip and at the device level, and then we can get the use features that way. We also probably need to adjust the prediction model to accommodate the mobile phone data because obviously we may not have all the information in the mobile phone data. We may not have all the information for the data, for the corresponding data in the survey data sets. Finally, we will need to develop a validation methodology. I think I'm running out of time, but I hope I have a couple questions, couple of minutes to answer questions. We don't have questions, okay. But thank you. I hope you enjoyed the presentation. Yeah.
Sorry. Yeah, thank you.